Choosing a cable tray, it might seem like a pretty minor detail in a big project. But trust me, it's a critical engineering decision. And if you get it wrong, the cost implications, they're not just big, they can be absolutely staggering. So let's break down how to get it right every time. How staggering are we talking about? Well, how does a 22% jump in material costs sound? All from a single wrong choice. And look, that's not some made-up number. That's from a real-world project, a pharmaceutical plant to be exact. That's exactly the kind of expensive, painful mistake we're here to help you avoid. So a lot of the time, the whole decision really boils down to this one question: ladder tray or perforated tray? They're two of the most common solutions you'll see out there, but here's the thing. They're built for completely different jobs. The real challenge is knowing which job calls for which tool. To make that right call, we've got to start with the fundamentals. I'm talking about the actual anatomy of the tray, because the way each one is built is the key to understanding its proper application. Put simply, how it's made dictates what it can do. Honestly, this is the perfect way to visualize the difference. I want you to think of a ladder tray as an I-beam. It's engineered for maximum strength using the least amount of material. Now contrast that with a perforated tray. That's more like a flat plate, designed to give you consistent, uniform support across its entire surface. Two totally different philosophies. So let's look a little closer at that I-beam structure. With a ladder tray, you've got these two side rails doing all the heavy lifting. They carry the main load, just like the top and bottom flanges of an I-beam. The rungs in the middle, they're really just there to hold the cables in place. It's this specific geometry that gives it that incredible load-to-weight ratio. It's a real structural powerhouse. And on the other hand, we've got our flat plate, the perforated tray. Here, it's a continuous, punched base that distributes the load across its entire width. This gives you fantastic, uniform support, which is absolutely ideal for smaller cables or bundled cables that might otherwise sag between the rungs of a ladder tray. But there's a trade-off, right? This design is just less efficient when it comes to handling really heavy loads and long spans. So, these deep structural differences, this whole I-beam versus flat plate idea, they directly lead to three measurable engineering factors. You should think of these factors as your go-to test for matching the right tray to the specific demands of your job. First up, load capacity. And this just brilliantly illustrates the difference. A ladder tray is your heavy lifter, no question. It can easily handle loads from 75 up to 200 kilograms per meter. It's built for those beefy power cables and for long spans between supports. A perforated tray, it's really designed for lighter duty, think in the 25 to 75 kilograms per meter range. Absolutely perfect for data or instrumentation cables. Okay, second factor, cable support. How does the tray physically hold the cables? Well, a ladder tray supports them on individual separate rungs. This works perfectly fine for big, rigid power cables. But what about smaller, more flexible cables? They can sag or droop in those gaps. And that is exactly where the perforated tray's continuous base really shines, giving you that uniform surface to prevent any sagging at all. And third, airflow. Now, this is a big one, and it gets overlooked way too often. A ladder tray's open design, it allows for maximum air circulation, which is great for keeping cables cool. A perforated tray, even though it's ventilated, is still 50 to 70% solid material, which obviously obstructs some of that airflow. So, why does this matter? Well, poor ventilation can raise your cable temperatures, and that could force you to derate their ampacity, meaning they can't carry as much current safely. It's a huge deal. Okay, we've taken a good look at the anatomy and the three key performance factors. Now let's pull all of this together into a simple, repeatable framework so you can make the right decision every single time. Here it is, just 3 simple steps. First, you've got to calculate your load. Add up the total weight of your cables per meter to figure out exactly which load class you're in. Second, assess your cable mix. Are you running big, heavy-duty power cables, or is it mostly bundles of smaller data wires? That's going to tell you what kind of support you need. And third, evaluate your airflow needs. Is keeping those cables cool a top priority for you? Just answering these 3 questions will point you straight to the right solution. And that really is the ultimate takeaway here. This choice isn't about one tray being good and the other being bad. It's about picking the right geometry for the specific loads and conditions of your project. So when you're in doubt, don't guess. Just remember this simple principle. The structure is always the guide.